So I think most of the, the participants, they are coming from the different, they are the teachers of schools. So today we are, I'm going to, share some of the, the examples and some of the competition thinking area we will share with you. And I mean, as all of you are teachers, so you know better than me to how to teach to your students. Only point is like that today we are meeting in this area like a computational thinking. There's a new term. It's a very important term for nowadays. So in industry also, like in CIRAC, we are also, it's a we are working different computational aspect. Like in CIRAC we have the supercomputers and different others area we are working. It's a AI and machine learning challenges. Currently we are doing different projects we are doing. So but the computation is a very important part, in all aspect, not only in engineering but also in the, like in education and training aspect. So the background is little bit, we will start from the background side. Like it's a huge demand of the computer skill is required to introduce this kind of computation thinking. As we participating in the revolution, we need to train our children on skill for the digital age. uh, as I already mentioned, that computational thinking involves understanding the problem, designing a solution. So we need to think about the problem. If we can give some problem to the our students, so students need to understand the what is the problem, and they need to design the solution. They need to expressing it in the form of the human or machine can execute. So already US and UK, they are already moved beyond teaching digital literacy. France, Spain, also in South Africa also, they are also using this computation thinking already in their course curriculum. Like India, we are in the transition state. We are also promoting like a bring computational thinking to the school. All of you know that the CS Pathshala is one of the important initiative by ACM India. Uh, and there are different institutions like IIT Bombay. There is some department that's educational technology. They are also doing very good job in this computational thinking area. So and similarly in Amrita University. So I am saying that this area, it's a very important area for the teachers as well as the students from the schools, so that we can learn little bit how we can formulate the understand the problem in better way. Okay, and designing the solutions and expressing in front of the human machine interaction. Okay, so this is like you only just as I'm thinking this is the fast lecture, so I'll just give some introduction what is computation thinking, because the in this the definition itself is saying that the thought process involving the formulating the problems and their solution, so that the solutions are represented in the form that can be effectively carried out by the information processing agent. Okay, so this is very important. Like we need to first of all decompose our we need to understand the problem, and we need to decompose whatever the problem given. Then you need to find out is there any kind of pattern is there or not. uh, is there any point someone is saying something? Okay, so as pattern recognition is also is the part of that. Then we need to think the kind of abstracting, and we need to write some kind of algorithm kind of thing. It's not like we need to write any program in the computer. It's not like that. But if someone is given to the problem to the children or someone else, so he need to understand or decompose the problem, and then identify the patterns. What are the patterns there within the problem, and then after the abstracting the problem, we need to identify some kind of steps in kind of we need to write some kind of pseudo code to write to understand the problem. So these are the beauty of the computational thinking. I already mentioned that the IIT Mumbai, Bombay, they have already working in this area. They have released series of books in the name is the Computer Masti. So it's the entire series. I mean, from the level 1 to level 8 is already available in the internet. So as a reference, you can also, I mean, use this kind of books. You can follow this kind of books. So okay, so in this lecture we will have different we will talk on different examples. Like this is a small example. Like someone is planning for the picnic to the water park. Then what should he do? This is my problem. So the Jyoti is saying that we will book the ticket and go. So is it possible to book the ticket before collecting the names of those who like to go? So first of all, we need to collect the names who want to go. So that's the steps. So because there are different steps, so if we're going to arrange some picnic, there are also some different steps are there. Like make an announcement about the picnic, ask student to give their names, then we will go for booking the tickets, and we will then arrange for the travel to the water park. Okay, so every activity, so every daily activity also has a sequence of steps that need to be followed. That's the beauty of the thinking process. So we will think in such a way that so that we can have a sequence of steps, we can follow the sequence of steps. So any activity has a sequence of steps. First list the main steps of the activity, then we will go for the detailed steps, then list the steps help in carrying out the activity easily. So why I am giving this kind of example? Because so in daily life also we are also trying to follow some steps. So in the example of the computer thinking process, so whenever we will interact with our students, we will say in such a way so that the student from the class 1 or class 2, they can think the what's the problem is given, and they can try to map those problem. Okay, map those problem in different steps. So steps are very important, understanding thinking is very important. Okay, so uh, so, so go to the next slide. So there are different arguments are there. Like a competition thinking is just another buzzword of the programming. So is it a programming language? So do you agree, yes or no? So if you think it is a programming language, or you may not thinking is a programming language. So can you answer this question? Anybody from the audience, anybody of the teachers, can you answer? Like computation thinking is just another buzzword for the programming. Do we agree? Yes or no? Is there anybody from the audience can give this answer? Yes or no?
Yes.
Okay, someone is saying yes. Good. Anybody else? Okay, so no problem.
Yes, sir.
Yes. Okay. So I, okay. So let's see. So find a neighbor with the opposite. Someone is saying, someone will say yes, someone obviously will say no. Okay. So there are different contradictions are there. Okay. But there are both way we can think. The computation thinking CT is the same as programming language because everyone's talked about it in X context of programming. Okay, there is some logical approaches are there. Okay, and there are step by step follow. So these are the different just I'm taking some kind of pointer. Okay, so this is a logical approach and step by step approach. So but on the other hand, if you can think, computation thinking is not same as the programming, because the ideas have been explored in the other domain as well. So if I'm planning to have a picnic, and if I say please write some steps, it's not required any kind of writing any program. So only you need to think. It's about the thinking, not programming. So no limitations. So there is no limitation. If someone is coming from the literature background, someone is coming from the computer science background, geography, history, so each and every subject, if you see your subject, there are also some kind of steps or thinking is required. Okay, programming is only the subset of the computational thinking. So if we say the programming, it is only the subset of the computational thinking. This is mostly the problem solving. like the like all of you the teachers, you know the reasoning very well. So if I give you some reasoning problem, that's not like any computational problem. It's the thinking problem. You need to think, you need to understand the problem, you need to find out the what are the different steps in between to resolve the problem. So like here also, like my background is electronics and computer science engineering, but when we sit to understand a problem, we need to sit with a pen and paper. We need to first of all identify the problem and need to discuss with our colleagues. So what are the different steps are there within the this problem? Okay, so what I am trying to say that this is a problem solving. uh, so uh, so more thinking attitude is required. Okay, so somebody is say yes, computation thinking is I mean related to the programming, and somebody will say not, it is not directly with the programming. But mm, we will say that computation thinking is the only the programming is the only the subset of the computation thinking. Okay, understand? Okay. So, in summary, we will say that learning of computational thinking is not the same as a learning programming. It's completely different. Computational thinking is only the computational thinking is a superset of the skills, which programming is one skill. So, logical thinking is very important. Logically, you need to organize each and every formula, each and every steps. Okay. So, there is another activity. So similarly, can I ask the second question, like computation thinking is relevant only for topics studied by computer science students? So is this the computer thinking, this is the subject is only for the computer science students? Uh,
Definitely not.
No, sir.
yes, yes. So agree with you. It's most of the, I mean, so we will discuss. Computation thinking is not just a computer science topic. So each and every background of the teachers can think and think different steps. Okay, it is a broader and can be found in several disciplines. So it's an interdisciplinary think this computational thinking. Okay, so what is the takeaway? Takeaway is competition thinking is not automatically awkward. There's the only point is that why it's a term, why it's a buzzword, because it's not you can automatically awkward. We need to learn. We need to learn little bit. We need to learn how we can think. What are the different steps? So learning competition thinking is explicit training. Maybe sometimes required. Okay, for the for the students. Okay, like all you are all the teachers. So when you are going to appear in different examinations, there are also I mean at the time of examination they can ask like a different mathematics, some basic mathematics, they can ask some kind of reasoning. Okay, so you know better that how you can solve those problems. Okay, so but I will say that each and every aspect of thinking, if you have a proper learning procedure, if you gone through any learning procedure, then you can learn in a better way. Okay, so like, for that completion thing is very important. So, some work already I mentioned that IIT Mumbai is currently doing in this area. ACM India CS Pathshala. If you visit this, this site, you will get the different kind of resources available. I am also taking help from these websites. Similarly, in Amrita University, so there are many more. Maybe I have missed something. I mean, I missed someone, but there are these are the major institutions currently they are working in this area of the competition thinking. Okay, so these are my basic references. So then I will move my next slide. Um just give me 1 minute. So now I will go directly to the actual topic. Is there any questions from the audience? If you need to understand, I mean, the first slides I try to share about some computation thinking introduction and background, so that we can start in a, in a different mood. Like it's not like a we are going to learn any computer programming. We are not going to learn any. We will not write any code. Today is my two session. We will not write any code. So only we will think. We will try to participate in different examples. And Do you have any questions? Whatever slides I have shown, so we can ask. Okay. Or anyway, you can also write your queries. You can ask maybe after this session. Okay.
So can I ask a question?
Yeah. Please, please.
Okay, I am Vasanthi Rajendran from Rajiv Gandhi National Institute of Youth Development.
Yes, ma'am.
I just want to know CDAC, what
Right.
is it doing, sir, for, what are the activities undertaken by CDAC to promote computational thinking among teachers across the country?
Right, right. Actually, CDAC, ma'am, is a Center for Development of Advanced Computing. It is under Ministry of Electronics and Information Technology, Government of India. In CDAC, there are different, we organize different training session for the different people. Like I'm giving some example, like in CDAC, we train the faculty. There are some faculty development programs are there. We organize different faculty development program of the different engineering college as well as polytechnic college, ITI students, ITI teachers, to for the like example, like a area of artificial intelligence, machine learning. So these are the different buzzword in this area. So how we can use artificial intelligence and machine learning, try to resolve the solution, any problem, try to resolve the problem. Okay. Like my background is the area of signal processing. In my lab, we worked and we try to understand if I'm saying in English, but not English is not my mother tongue. My mother tongue is maybe the Bengali. So I am more comfortable in Bengali rather than English. So, but when I am saying in English, is my computer can understand that this is Mr. Jayanta is saying? So, so what kind of learning is required? What kind of steps is required? What kind of machine learning approach is required for that? So we need to train our computers. We need to train our systems to recognize the voice of Jayanta Basu. So this is only examples I am saying. In CDAC, we are organizing different training program for the faculties as well as for the security aspect. We train the defense personnel like police or army, Indian Navy, airports. So each and every sector we try to train try to train the Indian population in different way, like a cyber security, cyber forensic. So in that area is a very interesting area for the security aspect. So we trained. There is another team. It's not my team. There is another team. They are working the cyber security, cyber forensic. So, madam, actually, I am saying that CDAC is a research and development organization. The one part is the academics and training is one of the important component, and other part of the activity we are carried out in CDAC is the development and research.
Thank you, sir. Thank you. Thank you.
Thank you, madam. So this is also, in this lecture also, I am trying to give some kind of ideas like what are the systematic listing, counting, and reasoning, because this is the topic of, this is my today's topic. Okay, so so I try to restrict myself in this topic. So listing, counting, and reasoning is a very, known term to all of you. All the teachers and all the audience. So it's a very common term. So, but I will start like in a very novice manner. Like what's the number? So, so can you tell me your favorite number? So if I can ask this kind of question to any children, so they can say, somebody say, okay, 5 or 7 or 4. So there are many different numbers. So these are the numbers. Okay. So can you say what is the smallest number? Like here, the 2 biggest number or the largest number? So these why I'm saying this kind of slides, it's a very, we are going to step by step we are going ahead from the difficult problem. So these are the numbers we need to count, like a 2, 3, 5, we need to count. So, okay, so like a next my question, what is your favorite color? Like my favorite color maybe is red. Okay, so student will say my favorite color is red, but within red there one number is written like a 1. Okay, so okay, again I am taking one laser pointer. So if I am saying okay, yellow is my favorite color. Okay, so within the yellow I have written 2. So the question is, what is your favorite color? Okay, student will say yellow. So now the question, how many times does your favorite color show up here? Like if someone is saying like this is orange is my favorite color, so there is a 2 times orange is coming. Okay, so the question step by step, I'm whatever question I'm asking to the student, a little bit complex. Okay, so this is another like another question. So it is a very important I mean slide to learn the numbers, to identify how much, like you for the one, like a 1 balls are there. Okay, for the 2 there is a count 1, 2 balls are there. So there are for the 10, like a 10 balls are there. Okay, so we in this way we train, I mean our student to the children. So I think all of you, all the teachers already are habituated of this kind of mechanism. So I am not saying anything new for all of you. Why I am saying this kind of slides? Because uh, thinking, I'm saying this kind of slides so that student can also think that how we can count the numbers. Okay, okay, so thinking in mathematics, in some mathematics, number counting help us to thinking. When we think, we can imagine, so it helps to solve problem. Thinking is useful. See the below, I'm saying here below story. So do you remember this story is very I mean very old stories. I mean for all of the student, they can learn these stories like a tortoise and ducks. So sometimes tortoise just opened the mouth. So what happened? So without thinking, tortoise just opened his mouth. So we need to think that what should be our next steps. So thinking, it's a very important process. Okay, so it's counting. So do we know how to count? Yeah, obviously, like I will say that 1, 2, 3, 4, 5, 6, 7. Okay, so how many black dots? 1, 2, 3, 4, 5 dots. So and can you find out the how many gray dots are there? Okay, so 1, 2, 3, 4, 4 gray dots. So one by one, slide by slide, I am just complexing my my examples. Okay, so if I just put all these dot in a row, can you spot the gray? Okay, so I will say that if I putting these dots in a line, so I will say it will be easy to count. Okay, rather than it's a jumbling. If we say that we will put the all the dots in a very, I mean in a line, it will help. So sequence is matter. So we will much comfortable if these balls or dots is putting in a sequencing manner. Okay, so it will help to count. So the question is, there is no order in the left hand side. Okay, but there is some right hand side, the dots are in line, so it's a very easy to count. So it's you can easily count like a each and every line there are 5 dots, so there are 4 lines, there are 20 dots are there. Okay, but if we say how many dots are there, so you need to count one by one. Okay, so sequencing or like a listing is very important. So am I clear? I mean, do you have any question? So just you stop me and ask me question. So because it's a very, I mean, important, but it's a very basic thing. Whatever I am saying, it's nothing new to all of you. Only I'm trying to say, like, if I put all the thing in a sequencing manner, so it will be better to help. Okay. So, okay, there's another example of a shape. Okay, so how many squares are there? So you will say how many colored square, like a 1, 2, 3, 4, the 4 squares are there. So maybe there is another square, the outer square. Okay, so how many colored squares are there? Maybe the 4 squares are there. How many squares have the black dots, like a 1, 2? Okay, so how many square don't have any dots, like a 2? So if I put this kind of question, to the children, or to our to our students, so they can also feel comfortable and try to find out the answers. Okay, so I'm going to a little bit in different way. Like in our class there are different seats are there. So if I will say that, can you tell me how many seats are there in the classroom? Is the number of seats same as students numbers and chairs numbers may be same or maybe sometimes different. Okay, also we use the mathematics in daily lives to share the food equally. Like if we need to slice the pizza, I have taken a 8 slice pizza and we need to share. So we need to share food. So to share the seat of class every time. Okay, everyone gets to sit. Okay, movie hall, within the movie hall everyone with a ticket gets to sit. Okay, so each and every day of life, if you think, we use the mathematics each and every time. Okay, so there's another play. So how many fingers I'm showing? Maybe two, maybe three. Okay. So if I say, just show me some of your fingers. Okay. So how many fingers you have? Maybe two. Okay. How many fingers? Like a four. So in this way, we try to convince our student to how to count. I'm not writing any, code, any programming. I'm saying that counting is one of the important part of the thinking. Okay, if if we say that if we count very well, then we can think the problem in better way. Okay, so it's a what is the procedure of counting? Here are five balls are there. Someone is trying to count like a one, two, three, four, five, or someone is trying to count in different way, like a one, two, then come three, four, five, six. So in different way, because it's a jumbling, it's a jumbled, it's not in a sequence. So counting should be correct. So here 2 points should be it is a correct count, it is a wrong count, because the students, he or she may be choose in the different direction, different path. Okay, so many ways to count correctly. So speaking out aloud while counting, we will say the student speak aloud, say, try to aloud at the time of counting, one, two, three, four, five. Okay, touch and count. Okay, move and count every time. Draw object of your notebook and count. Repeat count once again. So these are different way of way of counting. They are maybe different, so you can maybe think in a different way. But here I am trying to say that the counting is also very important, and each and every student or teacher, they can count in different way. Okay, so speaking, if you say in a loud mode, like a one, two, three, four, five, maybe you are correct. Okay, we will say that touch and count, like this is one, this is two, this is three, and this is four. So this the very important to how to count. Okay, so move and count, we will put like here, one, two, three, four, five, six items are there. So I moved, this is one, then I take this book into, so I try to put in a sequencing, I try to put in a line, so that it will help to count one, two, three, four, five, six. Okay, so there are the different procedures, like you can draw in your notebook, like a different way you can draw. Okay, and we will say that repeat, revise, हम लोग बोलते हैं you need to revise up at that after your task is over. Why repetition is important? Because again you need to go back and recount. Okay, maybe it will help to correct your correct your thinking process in better way. Okay, so check and count, already I mentioned this thing. Okay, counting mechanism, I already mentioned that speaking aloud is important, touch and count, move and count every item, and draw is another thing, and you can repeat. Okay, so here is some question to all of you. Here is a group of many different objects. Can you count only those things to move, that move? Can you count only those things that move? Okay, so I think already you have started thinking, like how we can say it, like a thinking like this is car, so it's a movable. So this is aeroplane, this is movable. This is a book, so it's not movable. It's not. This is apple. This is tree. This is also movable, but not one place to another. Okay. This is bicycle. This is clock. This is one worm. Okay. This is a computer. This is a bug. So I think these are maybe the correct answer. Okay. So whenever we will give some kind of we will show some kind of object as in the same time you would start thinking like here the question is, can you count only those things that move? Okay, so these are maybe the correct answer. Okay, or maybe you can think like a tree is maybe one of the things that can move here. I mean, the branches they can move, so we can take this tree also. Okay, so I mean, is it understandable to all of you? I'm trying to, I mean, show you some slides so that you can understand what is the counting and how we can count, what is the importance of listing. So is there any question to all of you? I mean, I'm asking to all the participants, do you have any question up to that? Okay, okay, no problem. So so in counting is very very, I mean, it's a fun, counting is like a fun, like this is a I mean uh, a die of 5. Okay, so again I will take laser pointer. This is a 5, 1 2 3 4 5, so 5 6 7 8 9 10. So can you count starting from the given number? If this is 3, then 3 4 5 6 7 8. Okay, this is 6 7 8 9 10. So this is very I mean counting is very, I mean, fun for the students. Okay, but how we are going to present to the student, how I mean, is the students is thinking? So that's the challenge to us, to all of us, to all the teachers. We have the challenge like if is that our student is thinking what I am thinking. Okay, so here is also one query. Do we always count from one? What do you think? Like here I'm giving like a 5 dots, 1 2 3 4 5, so I'm starting from 1. So if I add two more objects, should we start from again 1? Okay, maybe we can start 1, not a problem. But maybe there is a 5, here is a 5 objects are there. So we can say this is 6, 7. So counting from 5 is also possible. So we are starting. So as we know, this is already we know this is a 5 balls. I mean, 5 balls are there. So we can start counting. This is 6 and 7. So total 7 balls are there. Okay, so sometimes we start to count from 1, or sometimes we start to count in different number. Okay, so these are the different activity that how many alphabets. I mean, if I ask somebody what is your name, he or she will say my name is Amitav. So his name start with A. So how many students they have the starting alphabets A? So if we can put all those name, collect all those name, and try to find out the, I'm try to find out the counts of the name begins with A. Okay, so when we see this kind of activity to the students, students also try to interact with the teacher and try to say my name is Amitav, or my name is Oyan, something like that. Okay, so then we will go to the puzzles. Okay, this is also very very important area of this subject. Okay, so what is puzzle? A question that makes you think. So we all love puzzles. We all love to solve the puzzle. Okay, so the question that makes you think. Okay, today we will a little bit I mean start with some easy puzzle like a shape. Okay, so what is this shape? So this is square. Okay, four equal side, standing or slipping lines. So it's a square. Okay, so are these are squares? No, this is rectangle, this is parallelogram. Okay, so this is not square. Okay, so we are trying to find out, we will trying to give you some puzzles on this shape of square. Okay, So the puzzle one, uh, how many squares are there? Can anybody say? I mean, try to interact with me so that I can also get some feel that you are also involved with me, because the
Three,
computational
three.
thinking is a thinking process. I try to, I mean, I request you to think when I'm saying some kind of slides, like how many squares are there? It's a very easy. It's only
Three,
two.
sir.
One, yeah, one or two. No, no, no. It's not three. I mean, square is one and two. Three is the. I mean, outer side is a rectangle. So
Two,
in
sir.
this puzzle, we will try to find out the squares. Okay. So this is one square. This is another square. Okay. So we will try to find out how many squares are there. So answer is two. Okay. So next, how many squares are there? Anybody, please? Oh,
Three.
great. Three. Absolutely
Three,
correct.
sir.
One, two, three. Three. Agree. So there are three squares. Okay. How many squares are there?
Five. Five.
Okay. Anybody else? Any other than five? Okay. So five is five is correct. Five is correct. This is five. Why? Then I need to think why five. We need to decompose the problem. So I have given a problem. I have shown one. One image on one shape. The answer is five. So what are the what are the problems? Like there are four square. This we call is the insides. Okay. So we are decomposing the problem. Okay, this is the four square and this is another square. This is a big outer square. So I am just try to break the problem in two steps, inner square and outer square. So I am thinking in that way. So answer is 5 is correct. Okay, so how many squares can anybody try? How many squares are there? Take your time, no problem. Try to think and try to decompose the problem.
Six, sir.
6. Okay, anybody else?
दो ही होंगे ना इसमें तो
How many squares are there in this puzzle?
There are only two squares.
Yep. Pardon, please.
There are only two squares, sir.
Okay, 2. So one answer is 6, another answer is 2. Okay. Is there anybody else? Okay, no problem. So actual is the just 2. 2 is the correct answer. Why? Because if you think there is only just there is a one inner, this is the inner square and this is the outer square. So I mean if you are thinking 6, you are thinking this is another square. Okay, you are thinking this in the this inner square, maybe some in hidden squares are there. But I mean this is not a square. This is a different shape. Okay, just I'm trying to give some kind of explanation. So the this shape is basically this is the shape. Okay, this is the shape. This is the shape of this. So this is not the square. Okay, understand? So that's why it's not, we will not count as a square. So the answer is correct answer is 2 because one is the inner square, second one is the outer one. Okay, so now how many squares are there? How many squares?
10.
Okay, 10. Anybody else? So we try to think and try to decompose the problem. I mean, what are the inner square? How many? What are the outer squares are there? You think in, in that way. Okay. Is there any? Someone is saying 7, maybe. Okay. Is there anybody? Okay, no problem. Just think in
10,
different way.
sir.
Okay, great. 10. So let's break down.
There
Okay.
are 10
Okay.
squares.
Okay. So this is my inner square. This is my inner square. How many squares are there? Look at only the
5.
inner square. How many squares? 5. So we will write the 5. Okay. So this is my external square. How many squares are there? Again, this is
5,
5.
sir.
Okay, great. So how many squares? 5 plus 5, 10. So 10 is the correct answer. Okay. So So I'm trying to say that only one shape, square. So you can create different puzzles and try to think and try to give this kind of example to your student also, so that they can start thinking. Okay, only thing the student have to knowledge what is square. Okay, so this is another puzzle. Can you solve this? How many squares? Can you try?
7.
Seven,
Okay,
sir.
7.
7.
Good.
7. Sir.
8, sir. 8.
Okay, 8.
8 has a
Okay, anybody else? Okay, so
5, sir.
yeah, pardon please.
there are
How many? Okay.
7,
Okay,
sir.
7.
7.
So there's a no answer is given. So this is activity for you, but we will try to decompose the thing. Okay. So this is my square. Okay. So within this square, there's a 1, this is 2, this is 3, this is 4, and outer world. So we will say this is 5 here. So here is another square. Okay. So number 6. So here is another square as the number 7. Okay, so if you anybody thinking this is the square, like this is the square, this not a square, this is a rectangle, that may not be possible. So maybe the answer is correct answer is 7. So is it? Are you convinced with me? If you're not convinced, you can, I mean, you can also, I mean,
Yes, sir.
counter to me, not a problem, because it's an interactive thing.
Yes, sir.
Okay, okay, okay. So how many squares? Again, you just try to think how many squares are there. Okay, so try to decompose. Okay, so okay, I'm also trying with you. So this is one square. So 1, 2, 3, 4, and outer, it is the outer one. This is total 5, and this is another square here
6.
plus 1. So this is equal to 6. Is there any other square? I think not. I think not. Okay. Okay. So, this is the end of the, I mean, puzzles things. Oh, are you enjoying these slides, or I'm too fast? I mean, do you need? I mean, do you have any question up to that? I mean, here up to that, I'm trying to, trying to share some information related to numbers, how to count, and also try to, decompose my problems. Okay, try to break down my problem. I have given I have shown some kind of squares and try to decompose the problem in a in a small problem. Okay, okay. Again, there is another, I mean, activity. uh, Here is a farmer Jack, needs your help. He loves his animal, but needs help in taking care of them. Can you help him find how many animals he has? Okay. So from the next 2 3 slide, I will show you some kind of show of animals. Like this is the cow. So how many cows the farmer have? Like I'll try to start counting 1, 2, 3, 4. Okay. Again, I will take pointing option laser, like a 1 2 3 4 5 6 7 8 9 10 11 12 12 cows. Okay, so it's a in sequencing, it is in a line, so it's a very easy to count for me. Okay, so this is a goat. So how many goat is there? Okay, so can you help me? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, 16 goat. Okay, so how many hens and eggs are there? So why I'm showing this kind of, this is a very simple, but why I'm showing, because this way we will help to count the different animals, like two animals, like a hen is there, so there are different eggs are there. Okay, so at least we will say to the student, like there are cows are there are goats are, how many goats are there are two hens are there, they lays egg, how many eggs are there. So this way we will start counting each and every time. Okay, so this is basket one and basket two. If I will say how many mangoes are there, in basket one there are seven, and basket two another seven, and four are lying. Okay, lying around here. So how many baskets? 7 plus 7 plus 4. Okay, 14 plus 4 18. So 18 mangoes are there. So it's a very easy for us, but do you know, it's this is very difficult for the class 1 student to think how many mangoes are there. Okay, in basket 1 there are maybe 7, in basket 2 you need to count each and every time, you need to count. Okay, so we try to give some kind of problems, and we and like this is the one query, like a farmer Jack carries the mangoes to sell it at the shop. So how many mangoes in all has he carried to the shop? So he has taken the all mangoes, like here is the 18 mangoes are there. Okay, so how many mangoes did he count? Like 18. So are you sure you have counted all mangoes? So for that, we need to recount, we need to repeat again. Okay, so there are different steps to count. So similarly, here we will say that this is another example. Okay, so this is the example, like how many bananas are there in this box? Like a 1, 2, 3, 4, 5, 6, 12. So if I will say how many more bananas would you require to make it 20? So we will say that, oh, it's a very easy, 20 subtract, I mean 20 minus 12 is 8. 8 is the answer. Okay, for you it's a very easy, but can you think like how, I mean your student can think, I mean I mean um, so I know all you are all at the teacher, you know better than me how to teach you student. I'm not, I mean, going to that portion. Here I am saying that thinking is important. So I'm given a box of bananas, there are 12 bananas, I'm saying we need to create 20 bananas. So how many more bananas are there required? Okay, similarly these are the kind of activities. These are the apples are there, how many more, I mean tomatoes are there, how many tomatoes are required to fill this box? So if you just give this kind of examples, so I mean your student also I mean learn counting and also a systematic manner. So that's my objective. Okay, this is little bit I mean it's a little bit difficult problem, not difficult to you but difficult for the children or students. So there are different this is a grid. Okay, this is a grid of information. Okay, so we need to fill this grid with some numbers. There are 2 digit number, there are 4 digits number, there are 7 digits number, there are 8 digits number. So can you try yourself to fill this kind of I mean to try to solve this problem? uh, can anybody of you try to say what steps we need to follow? So my question to all of you, um, if I've given this problem to you, from where you start? So how you think? What are the different steps you will think? So can anybody just guide me and help me to how to and to resolve this problem? Anyone from you, please? You can try. It's a correct or wrong. It's not thing. It's not important. Just you try. Because I know if I will give some time, all of you can I mean solve this problem. But what are the steps to fit the following numbers into the grid? Can anybody? Okay, no problem.
8 digits, sir.
Yeah, please, pardon, please. What's your first step?
We want to start 8 digits.
Okay, so you are saying that you will start with the, I mean 8 digit numbers. It's a
Yes,
bigger one.
yes.
Okay,
Yes,
okay.
sir.
So here is also 8 digit point. You can fill the here 8 digit, also here the 8 digit. Okay, no problem. So anyone else? Okay. I'm going to show you some steps, but I'm saying that whatever I'm going to say, this is not only the only steps. There are many steps. Like someone is saying that he will start or she will start from the 8 digits. It's correct. It's not wrong. Okay, it's correct. Okay, so why I'm showing this kind of grid to you, because I'm trying to share that you need to think step by step. Okay, so this is maybe the final answer, but I will go to the step by step manner. Okay, so this is my question. So we will start with a digit, only one digit number. Okay, so if you see this is 23 is a single digit for the two digit number, and here also the seven digit, like a seven digit number. So can you find out the two digit number here, two digit place? Okay, I'm just changing my pen so that I can also here there's a two digit number can fit, because this is the only two digit number. Okay, and this is a seven digit number. If you see, so this is the only one number. This is one number and this is also one number. So we need to find out where the grid these words, I mean these digits can fit. So, and if you see that this section, these are seven boxes are there. So I can say we can write seven digit directly here. Okay, so we can fit seven digit directly to that box without thinking. Seven digit and two digits. So strategy is like that. I'll try to find out the single digit number first, only one digit. 23 and 238366764. This is a seven digit number. So I try to find out this seven digit location and two digits location. Okay. Then I try to find out, um, I try to find out this is the four digits that, I mean, now we try to add two digits number. I mean, this is a two digit number. Okay, this is a four digit, this is also the two digit number. Okay, but if you think in if you see there's a 3125, so this is 3125 is possible, this is also 3125 is possible. Okay, so 31, so if you are thinking 3125 here, or maybe you can think 3125 here also, both of the correct, but you are not it, it's not confirmed. Okay, so we go to the next steps. Okay, so next step, we will try to find out this eight digit number. Okay, so these are the eight digits place. So this is six digits in between. Okay, so is there any six digit in between? This is the six digit, six in between, second place. Okay, so I can start writing here 9 6 4. Okay, 2 1 8 8 and 5. So there is no confusion. So this is another it's a end with 2, so we can write this 6 digit. Okay, so there is a no confusion, so we fill this 8 digit first before this 4 digit number, then we fill the last 4 digit. Okay, so this may be one procedure, and this is not only procedure. Okay, there are many steps. So in the solution of the grid, we can follow the different procedure. Okay, is it clear? I mean, uh, is it clear to all of you? I mean, I'm trying to resolve this grid solution and try to think and trying to write different steps and try to follow different steps. Okay, okay, and this is another puzzle. So the puzzle is filling the missing numbers. So you can try yourself, fill in the missing numbers in the pyramid. The I mean, problem is given the number in each space should be sum of 2, should be sum of 2 below it. If you are thinking this 2, this is coming because of 1 plus 1, this is 1 plus 1, sorry, this is 1 plus 1 is equal to 2. That's why I've written 2 here. So if you think this place, the below number is 2 plus 1. So what I will write here, 2 plus 1, 3. So this is 2, 3 plus 2, I can write 5. Okay, so what I can write here, this is 2, this is 2, 2 plus 2, 4. So what I can write here, 5 plus 4, 9. And what I can write here, this is 2, Can you say what I can write right here? This is 1. So 1 plus 1 is 2. So this is the another pyramid puzzle. Okay. So you can also create different puzzles and try to decompose the problem step by step and try to resolve. So similarly, I'm saying here the same thing whatever I am saying here, like a 2 plus 1 is 3. Okay. Then 3 plus 2 is 5, and then 2 plus 2 is 4, then 5 plus 4 is 9, then 1 plus 1 is 2. Okay. So these are the difference, these are the solution of to this puzzle. Okay. So I will say that puzzling is very important. So if you think about puzzle, then you can solve many things. Okay. So uh, so puzzle and great puzzle is very interesting to solve. Okay. uh, then I will we will come to another example, like it is fun to share our food, toys, clothes with others. Okay. So let's start sharing. Let's say I have 9 pieces of chocolate. Okay. First piece has 1 square, second piece has 2 square. Now come say it with me, the number of square in each piece of chocolate. So this is first piece. Okay, this is a 1, 1, 2, 3, 4, 5, 6, 7, 8. This is 9. These are 9 pieces of chocolate. The first piece has 1 square, so within that we'll say the first piece had only 1 square, second piece has 2 square, third piece is 3 square. So this way we can just fill. Okay. So how many squares are there? Can anybody add this? How many squares are there total? So can you? We need to count. Okay. So just we will add. Okay, we will add, because each and every cell number itself, I mean square, so 1 square, this is 2 square, 3 square. So if you can add this at 45. Okay, then we will say this 45. Now the problem is, now let's find out how many kids can get 5 squares, 5 squares of chocolate each with the available 45 squares. So my task, I have 45 squares. I need to divide this chocolate to among the kids, and the clause is each and every kid will get the 5 square of chocolate. So how many kids are there? I mean, how many, to whom, and how many kids we can give? So answer is, it's a very nine,
9.
nine. Correct.
9.
So nine kids. So 9 kids. But then how we can resolve? Because there are different shapes. These are the different shapes. Okay. These are the different shapes. So how you can share? This is only one. This is two. So how you can share these 45 squares among those 9 kids? So then we need to break those chocolate, because each and every day, if I in the dairy milk, maybe the 10 pieces are there, we need to divide in five members of the family. So we break it and give the 2 chocolates to all the members. So this is like a similar problem I have given to you. Okay. So try to think how many, how many, this is one square, this is another 2 square. Okay, this is a 3 square, but 1 2 3 4 5, 1 2 3 4 5, this is already 5. So I need to break and utilize this one square for the next. Okay, so I take this square for the next piece of square. So I have the 4 square, so I take 1 plus 4. So in this way I try to break and try to use the available piece of chocolate. Okay. So this is each and everyday life, we need to break this chocolate and share with our family members. So this is very interesting to share the chocolate with others. Okay. So these are the different steps. I'm not going to the detail each and every step, because it's whatever I'm showing, it's a self-explanatory. So we need to break each and every time. Only we need to think that we will break in less amount of time. Okay, we will utilize the available squares. Like here, I have the 5 squares. I have the 6 squares, so I break one. So keep it as a 5. Okay, break one and utilize this square here. Okay, so kids are happy. So now I'll show you some kind of mix and match problem. Okay, so I will say two half pants I have, two full pants, sorry, two full pants like a black and gray I have. I checked half shirt and one full shirt blue. Okay, this is a check shirt, check blue shirt, and this is the full shirt. So the I mean, how many way we can just mix and match? Okay, so it's a very easy. Now let's try to find out how many outfits have you have with the choice. Okay, you can wear the check shirt with the black shorts, gray shorts, and also the different black pants and gray pants. So this may be the one choice, this may be the other. So there are four choice. Okay, similarly, so that's the four outfits so far. Similarly, you can count, you can say these are 5, 6, 7, 8. Okay, now I try to introduce some. So there are total 8 outfits, just 2 shorts, 2 pant, and 2 shirts we have. Okay, so I'm giving some kind of condition right now. What if you can't wear a full shirt with a half pant? If you cannot wear full shirt with the half pants, so the condition is you cannot wear full shirt with half pants. The condition is. So now based on the condition, let's see how many different outfits is possible. Okay, so this is the problem. Okay, so the condition I have given only one condition. So condition is you cannot wear half pants with the full shirt. Okay, so let's start listing. So this is a listing. So let's start listing. So you can wear this and this is allowable, not a problem. This is also possible. Okay, these are four. Okay, so keep counting. So so is this allow full shirt with the half pants? This is not allowed. Okay, so because this is the condition. Okay, so there may be the total 6 outfits is possible. With this full shirt we can wear only the full pants, not the half pants. Okay, so I have given only one condition and number is reduced. Okay, so in summary we will say that we talked about how we can list and count objects to find the total. When there is a condition, when we find out the total count reduced. If I given a condition, obviously the total count will be reduced. Okay, so this is my final answer. Okay, total 6 counts. So we can also write in different way, like a half shirt we can I mean these are gray shorts, black shorts, black pants, gray pants. There are four, total fours. And with the full shirt there are four different combinations possible. Without any condition, then total is the 8. This is called a tree. Okay, so this is very important for the decomposition. Okay, so again I will start different problem. So do you have any suggestion, anything you need to share with me, if you have any doubt up to that? Okay, so I think it's a very easy to understand to all of you. Counting and tree is very interesting to learn. um, so now I have the different example. Again I will start with different object. Like there are two blocks I'm showing here, red and blue. Okay, so let's say the blue and red colored blocks. Let's see how many different ways we can build a tower of 4 blocks. Okay, so there are I mean there are two different colors of blocks. So the challenge or activities is like that, we need to build the 4 blocks. Okay, so this may be the one problem, I mean one solution, 4 reds or 4 blues. Okay, this may be the other, like red, red, red and blue, or maybe the red, red, blue, red, 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 blue, blue, red, blue, red, red. So there are different combination we can try. There are different combinations we can try and make the uh, this four the tower of four blocks. Okay, so there may be we will say the 16 ways. Okay, 16 ways we can make the tower. Okay, so if you just count and count each and everything, then we will say the total 16s. These are the combinations. Okay, with the only two colors, I have only the red and blue. So if I keep increase, or maybe let's see what. So similarly, I'm the keep increasing some colors. The same thing, four shirts, four pants with the red, blue, yellow, and black. So different combination is possible. Okay, and I've given one condition: you cannot wear shirt and pant of the same color at the same time. So red color and red pant is not possible. With the blue color, blue pant is not possible. Yellow and yellow pant is not possible. The condition, only one condition we have given, that you cannot wear shirt and pant with the same color. Then how many combination is possible? Okay, start thinking and start thinking in that way. So I have the red with the three colors, because I cannot wear red with red. Okay, so red and red with red is not possible. So similarly we can use the other color, like a blue with blue, not possible, but blue with yellow, red and black is possible. So this way we can start counting. Okay, so there are how many? There are total 12 combinations. So each and every time we need to draw and think that how many combination is possible. So this is our initial thinking process, that how we can resolve uh, mm, uh, this kind of problem. Okay, for the children, uh, uh, when we don't have any kind of multiplication, division, addition, subtraction is not here as a operator. If we think, then only we can use like this kind of tree activity. If we will do, then we can find out the final results. Okay, so these are the tree diagram. Okay, after beginning, this is a red shirt. Red shirt can possible blue, yellow, black, and blue shirt with the total. How many total? These are 12 numbers are there. So in summary, in lesson, I will say that in this session we continue to learn more about combining objects. Objects are combined using the of line methods by writing down the various combination of like a tower examples or this cloth example. Okay, so this is the end of my first session. Okay, so there are two sessions. So I have divided my session in this. After that, this is my first session. So now it's open for discussion. So is there any thing you need to discuss with me, or you need to share your experience when you teach with your students in similar way? Because now it's a pandemic situation is going on, so you need to teach your student. You need to prepare your presentation slide. You need to present to your students. So and also you try to give some kind of problem to your students, so that they can also start thinking. So I request to all of you, you can share your some ideas, whatever you were when you taught your student. You teach your student. Uh, you can share, or if you have any doubt, any query up to that, so you can ask. So it's open to you. I'm just stop sharing uh, here. So if you have any query, any doubt, I request you all to come up with your thinking process, so that we can discuss, or we can interact. Okay, so if you have any no such doubt or any suggestion, then I stop here. Okay, I request to the organizer to form